sources of chlorine, natural and man-made. CH3Cl is produced at the ocean surface, and some of them make it to the stratosphere. There's a bunch of chemistry that goes on in the troposphere. A lot of them are destroyed in the troposphere, but some naturally make it to the stratosphere. The other place are CFCs, and this is compounds that have chlorine, fluorine, and carbon, hence CFC. So we have multiple sources of these. So some of them make it to the stratosphere, and in the stratosphere, some things happen. We have a series of reactions. CH3Cl reacts with, you get UVC. There's plenty of it up there. Remember, we get CH3 chlorine. Another source, another reaction that can happen is OH radical, which there's plenty of that up in the stratosphere, can react with CH3Cl to produce chlorine plus other products. Not too worried about them. Okay, so we have several breakdown mechanisms of this to produce chlorine in this. And then that chlorine automatically goes to mechanism 1, mech 1, which you ought to be getting very familiar. Chlorine plus ozone yields ClO plus O2, ClO plus O yields Cl plus O2, net reaction O3 plus O yields 2O2. So this has devastating effect on the amount of ozone on there, but it's not as bad as you might think, because the chlorine exists really in a reservoir. And that's nice because it keeps it from reacting with the ozone. Most of the chlorine is in two reservoirs, HCl and ClO and O2. And so the reactions are ClO plus NO2, and you have to have some light for this. H nu gives you ClO NO2, and the equilibrium favors this way. So these are in equilibrium, and it favors the products. So that means you're not going to have a lot of ClO in. I mean, it does exist, but it's favored over here. So this limits, it reduces the effect of the chlorine gas in there. The other reservoir that you have is Cl plus CH4 to give you HCl plus CH3, and this CH3 eventually washes out as CO2, the series of reactions, CO2 gas. And so again, this is favored. The equilibrium favors this side. The equilibrium favors this side up here and this side down here. So this removes a lot of the reactive ClO and Cl from the atmosphere. The HCl, by the way, goes on to react with OH to gives us H2O and Cl. That's how it gets out. And again, this is favored on this side. And so our equilibrium are keeping our reactions favored to keep chlorine out of the stratosphere on this. So we have a series of reactions that they favor these reservoirs of ClO, and HCl act as reservoirs for chlorine. And they have a nice little diagram shown in your book in there. And so you have Cl plus O2 gives you ClO plus O2. And we remove and put ClO into there with the reaction of NO2 plus H nu, and we get ClO NO2. And over here we have Cl being removed from the stratosphere with the reaction of CH4, two reactions, and reaction with OH radical to give us HCl, and it favors this mechanism. So these are our reservoirs of HCl and ClO, NO2 that remove chlorine from the stratosphere. Not completely, and it's in equilibrium. So if these get low, this equilibrium will shift back up. A Chatelier's principle on there. And so you have self-limiting on there. On the other hand, if you keep adding chlorine and ClO in there, you're going to have problems. Eventually, these will wash out. The chlorine eventually, the HCl will wash out in water, in rain. So they'll eventually be out of there, but one chlorine atom will destroy about 10,000 ozone before it washes out. You have the same thing occurring with bromine. So bromine, Br plus O3 yields BrO plus O2, BrO plus O yields Br plus O2, same old mechanism. O3 plus O yields 2O2. Again, we have sources. We can form, just like we did up here, we can take bromine and react it with CH4 to give us HBr plus CH3, and the CH3 eventually goes away as CO2. And then HBr plus OH will give us Br plus water. And this time, this side is favored. So bromine favors this side on this reaction. And the BrO plus NO2 gives us in equilibrium BrO NO2, but again, it favors this side on there. The thing that's happening is there's a lot less Br in the stratosphere in all its different forms. So Br tends to be more, the equilibrium favors Br out there, but there's a lower percentage of Br in the stratosphere. So even though bromine is better at it, there's less of it, so it's not as important. The Cl is more important. That finishes up chapter 1, and we'll go on to chapter 2 next.